Hi everyone, welcome back to this video. Today's video we are going to talk about bubble sort. It is a basic sorting algorithm to sort the elements. Okay, first let's understand what is sorting. Sorting generally means sort or order a particular array or collection of elements into a particular sequence, that is either in ascending order or in descending order. So, in this video, first we will understand the working of bubble sort with an example, how bubble sort works, how the data is to be sorted using the sorting algorithm, and then we will write down the code. So, it is a comparison based algorithm. So, in this, we compare adjacent elements, and whenever we get a pair that is not in a specific order, we swap them. The swapping of elements continues until the array is sorted and no more swapping is required. So, let's understand it with the help of an example. Suppose an array is given which contain 5 elements, which are 8, 3, 7, 4 and 2. So, the index would be from 0, 1, 2, 3, 4, something like that. Okay. Here n denotes the number of element and n is equals to 5. Okay. So what we always do in bubble sort, we always take adjacent elements and compare these elements. If these elements are not in correct order, then we will swap them, otherwise move ahead. So correct order depends on you, on which order you are sorting the element, that is in ascending order or in descending order. If order is not mentioned, then by default we are going to arrange data in ascending order. Now we are going to sort this array in ascending order. So we will compare the elements. If right side element is smaller than left side element, then we will swap, otherwise we will move ahead. So let's compare first and second element of the array, 8 and 3. So, is the right side element is smaller than the left side element? Yes. 3 is lesser than 8. So, swap them. So, 3 will come here and 8 will come here. Remaining array will be the same. Now check next two elements. Seven and 8. 7 is smaller than 8. Yes, it is. So swap them. 7 will come here and 8 will come here. Now we already checked these two elements. Now check 8 and 4. So the right side element is smaller than the left side element. Yes. 4 is smaller than 8. So swap them. 4 will come here and 8 will come here. Remaining element will be the same. Okay. Now check 8 and 2. Is 2 is smaller than 8? Yes, it is smaller than 8. So swap them. 2 will come here and 8 will come here. So now we do not have any element in right side to check. So we will stop our loop over here. So this complete is known as first pass, and in the first pass, rightmost element is the maximum element of this array. Initially the whole array is unsorted, but now only n minus 1 elements are unsorted. So now you have to check from here to here. There is no need to see the last element. So again we will repeat the same process. Start comparing from the first element. Okay, so compare 3 and 7. If the right side element is smaller than the left side element, no, it is not. So we will move ahead. All elements remain in its same position. Now check next two elements 7 and 4. Is 4 is smaller than 7? Yes, 4 is smaller than 7. So we will swap them. 4 will come here and 7 will come here. Okay. Check next two elements 7 and 2. Is 2 is smaller than 7? Yes, it is. So again we will swap them. 2 will come here and 7 will come here, and remaining element will be same. Okay. Now there is no need to check 7 and 8 because 8 already in its actual position, so no need to check these two. So we will stop over here. So this is the second pass. At the end of the second pass we will see the second rightmost element has also came to its original place. Now this is our unsorted array 3 4 2. Now we have to sort this, so we will repeat the same process again. So let's compare 3 and 4. Is the right side element is smaller than the left side element? No, 4 is not smaller than 3. So we will move ahead. All elements remain in its same position. Now next move to the next two elements. Compare 4 and 2. So 2 is smaller than 4. Yes, it is. So again we will swap them. 2 will come here and 4 will come here. Okay. And remaining elements will be the same place. Now we don't need to check 4 and 7 because 7 and 8 are already in its actual position, in its right position. So we will stop over here. So this is our third pass. In this we had only made two comparisons, and at the end of the third pass 4, 7 and 8, last three elements of the right side, from the right side, come to its actual position. Now we only need to check first two elements 3 and 2. So again repeat the same process. So compare 3 and 2. If the right side element is smaller than the left side element? Yes, 2 is smaller than 3. So we will swap them. 2 will come here, 3 will come here. Remaining element come to the same place, complete same place. Okay. So now last 4 elements come to its right position, means all last 4 elements are already sorted. So now this array is a sorted array. After 4 pass we got as array in ascending order. So how many passes it requires? 4 to sort. And how many elements are there? 5 elements. Okay. So how to calculate how many passes are required? The number of elements minus 1. If number of element is 5, so 5 minus 1 is equals to 4. 4 passes are required. If number of elements are 10, then 10 minus 1, 9 passes are required. This is for only general case. So in this way bubble sort works. Okay, now let's see the code. Code will be very simple. There will be two loops in this code. First one is outer loop for passes and second one is inner loop for comparisons. Outer loop will be from 0 to n minus 1. N minus 1 because there are n minus 1 passes required. Now we will add a one inner loop in this outer loop. Inner loop is for comparisons. It will check adjacent elements. It will also start from 0 because we are always starting from first element in every pass. So we will understand why I have written here and minus I minus 1 over here, because in each pass comparisons are decreases, because at the end of each pass right side element will be sorted, so we don't need to compare them. Because in our previous example, so here in the first pass 5 comparisons are made, in the second pass 3 comparisons, in the third pass there are 2 comparisons, and in the fourth pass there is only 1 comparison. Okay, that's why I have written here and minus 1 minus I. Okay, so let's check it. N is equals to 5, so outer loop will be run 4 times. Okay, inner loop, when I is equals to 0, it will run n minus 1 minus I. It means 5 minus 1 minus 0 is equals to 4 times. So in the first pass 1, there are 4 comparisons are made. Okay, when I is equal run n minus 1 minus I, means 5 minus 1 minus 1, it is 3 times. So in the second pass, yeah, there are 3 comparisons are made. For I is equals to 2, it will run n minus 1 minus 2, so it is 2 times. Yeah, in the third pass we have made 2 comparisons. In the fourth pass, I is equals to 3, it will run n minus 1 minus 3 is equals to 1 time. So yeah, in the last pass we have only made 1 comparison, so this logic is correct. Okay, so inside that loop we are writing here one conditions, means what we are doing here, we are checking adjacent element. If the right side element is smaller than the left side element, so for that condition we are checking here if a of j plus 1 is smaller than a of j. So we will swap these elements. For swapping, we write this code. If a of j plus 1, if the element present at j plus 1 position is not smaller than the j position, so we will not do anything, we will not swap these elements, we will move ahead. So this is the code. In this code we have not done any further optimization. But suppose you are getting an array which is already sorted, or maybe the array is sorted after third pass, so there is no need to do sort it again, you don't need to check it again and again. So to do that, we can keep a check by declaring a variable swap, which keep track that in the inner loop is there any swapping happens. If it is, then set the if swap to be true. That means you have done swapping over here at least one time. But if not, then it remain false. You need not to do further iteration. Your array is already sorted. So this is the further optimization. With this, more time is saved. Suppose your array is already sorted and you have not done any optimization, then you would have to do checking multiple times, that you will come to know in the first time only that it is not swapped, and you will be break out from the loop. So in the below we will check if swapping was not done, then break from here only. If swap is true, then you will move ahead. Okay, so it will save your time. If the array is already sorted, then its swapped swapped remain false. So this if condition become true and your loop will break, you will come out from that loop. So you don't need to do check multiple times. Okay, so in this way bubble sort works, and you might have understood this. Okay, let's run the code and check the output to the channel. So we will finish this video here, If you liked it, then press the like button and subscribe. See you in the next video. Till then, keep learning. Thank you.